Hello, good afternoon, Prof. and Miss Rapita. Let me introduce myself. My name is Gede Ardhiarta Suta with student ID number 21130111069 from class 4D Mathematics Education. Now, I will present material about sets, relation, and function. Okay, what do you think about set? The set is a collection of objects with the same type, like a set of number 1, 2, 3, and a set of stationery like pen, pencil, book. Now, by listening or enumerating the elements or for finite sets, example is pen, pencil, and book. Now, by the explicit description of the elements, usually for infinite sets, is x over y when x and y element and x and equals y minus 1. Okay, now we have to get to know the symbol of sets. Number one is brackets. Brackets is indicating membership in a set. Number two is intersection. Now, the intersection of two sets A and B, denoted by A intersection B, is the sets containing all elements of A that also belong to B, or equivalency. Now, all elements of B that also belong to A. Next, union. Now, the union of two sets A and B is the set of elements which are in A, in B, or in both A and B. Okay, now I have a 9 model of set. Number 1 is subset. Now, R is a subset of S if every element of R are coming also element in S. Example like in the slides, R is equal subset 2, 3, and S equal 1, 2, 3. Okay, next power set. P is the power set of S denoted as 2 power S if it includes all subsets of S. The example like in the slide. Okay, I next the null set. The null sets are the empty set or void set, a set having no elements. In no element is called an empty set or void set. It is denoted by like in this slide. Now next is singleton set. The singleton sets, a set having only one element is called a singleton set. Example like the the slide. Okay, next is pair set. A set having two elements is called a pair set. Example like the slide is set of 2 1 2 0 3 4 9 and its other. Okay, next is finite set. Now the finite set is a set having a finite number of elements. E a a set where counting elements is possible is called as a finite set. Example set A is equal 1 2 4 6 is a finite set because it has 4 elements. Next is infinite set. A set having a infinite number of element E. A set where containing elements is impossible is called as an infinite set. Example like a set of all points on the arc of a circle. Okay, next is equal sets. The sets A and B are said be equal if every element of A is in B and every element of B is in A, and we write A not equals B. Okay, next is universal set. Any set which is superset of all the sets under consideration is known as the universal set and is either denoted by like that or S or U. For example, you can see in the slide. Now I will present it about a relation. A relation between two sets is a collection of ordered pairs containing one object from its set. set. If the object X is from the first set and the object Y is from the second set, then the objects are said to be related if the ordered pair X and Y is in the relation. Okay, next we have to know domain and range of the relations. The domain D of the relations R is defined as the set of all the first elements of the ordered pairs which belong to R. Either D, the domain D is defined as the set of all X such that X and Y belongs to R for X belonging to A. Next, the range E of the relations R is defined as the set of all second elements of the ordered pairs which belong. It is the range E is defined as the set of all Y such that X and Y belongs to R for Y belongs to B. Okay, next the example is let A is a set 1, 2, 3 and B is a set A and B, and R is a set 1A, 1B, 3A and 2B. Be a relation from A to B. Then inverse relations of R is, we got the inverse is symbol R power minus 1 is inverse. The inverse is set A1, B1, A3 and B2. Okay, the third material is function. What is function? Okay, given to non-empty sets X and Y. A function from X to Y is a correspondence or association that assigns its elements of set X to one element of set Y. Okay, next let us see the illustrations of the domains and the range. And here I have a domains. Domain is the starting point, and I have a range is the ending point. It's a two set with the non-empty sets in the domains and in the range. It's a non-empty set. Okay, here for the example I have two set. The set circle yellow is 1, 5, 7 and minus 1, and the codomain is circle with blue color is 0, 2, and 11. The yellow color is domain and the blue color is codomain. Okay, let's see the arrow. One is the way arrow is a 0 and 5 is 2, 7 is 2 and -1 is 11. Okay, we get the relation is 1 is a set of 1 0 5 2 7 2 and -1 11. We get the domain. Domain is a circle with yellow color. The circle with yellow color is a set of 1 5 7 in -1. The range or codomain is a 0 2 and 11. Okay, next we have a various type of functions. First we get one functions. A function f a implies b is said to be 1 if f a1 equals f a2 implies for all a1s and a2 is elements of a is also called injective. Onto function surjective, range of f equals codomain. Okay, next is bijective functions. A functions f a to b is 1 and onto functions, then it is called bijective function. Next, the identity functions. Let a be a non-empty set, then the function a the function e is defined by a to a e x equals x for all x is elements a is called an identity functions on a. It is a one-to-one onto functions. Next, the constant functions. Let f a to b defined in such a way that all the elements in A have the same image in B. Then f is said to be constant functions. The range of the constant function is singleton. Next is equals functions. Two functions f and g are said to be equal, written as f equal g if they have the same domain and they satisfy the conditions fx equal gx. Next, the inverse functions. Let f be a 1 on to functions from a to b. Let y be the arbitrary elements of b. We may define the functions denoted by f inverse b to a f inverse y equals x if fx equals y. Next, the composite function. The composite functions, let fa to be to b and gb to c. Be two functions from a to c which maps an element x elements a into g is fx elements c is called composite functions f and g and is written as GOF. Okay, that's all for me. Thank you, and I'm Sorry if I have a mistake about the presentation. Om Santi Santi